All right, good morning. I think it's time to get started. My name is Sophie Primick. I'm a materials engineer from UNSW Sydney. So bear with me if I'm not a super expert in drones, but I'm super excited to learn about everything related to drones in this session. And our first speaker this morning is, funnily enough, a fellow Austrian, Artur Lugmayr, so I won't mess up his name. He founded a startup called UX Machines in 2019, but other than that, he has several academic interests as well. And I just learned that he recently finished his second PhD from... No?
That's a hobby.
That's a hobby. There's a second hobby PhD going on with Artur University in Finland. So anyhow, the stage is yours, please.
Yeah, no, thanks for the welcome. So the second PhD I started as a hobby around 15 years ago, and I think it will be a retirement hobby sometimes, when I have the time to devote time to it. But I'm very happy to talk at the RAF event, this time, because until now I only had the chance to talk to RAF people when I was flying a Cessna 172, and you heard Melbourne Centre, please change flight levels, and it was from some PC-9, from Pierce Airport, and then you listen a bit, and changing flight levels, changing from IFR to VFR, and you sit in your Cessna, and you say, oh, that's because of me, and press the button, thank you, and so that was the thing where I'm happy to be here. So my name is Artur Lugmayr, so I started this company in 2019. We started off with data science stuff, so doing this one in an industrial context or for some projects, let's say in Perth, in Western Australia. And basically, we came to drones because of my big hobby, which is aviation. I have a private pilot license, and I want to do something in this space. But in my age, it's not very feasible to make a commercial license. Simply, we changed into drones. So we made the reorg and all the licenses. We are at the moment in the process of going through all these IREX things that we can get beyond visual line of sight licenses, that we can really fly our drones or test our autonomous systems also on board of the drones. In the past, I worked for projects for fault-tolerant system designs for Frequentis. I worked for quite a couple of projects for Nokia, where we dealt with sensor data or image processing projects there, and with digital television. And as part of my university projects, we worked in defense projects where we tested human factors in relation to submarines and all sorts of stuff, where we built some simulation environments. And our vision is really to become a scale-up in the year 2023. So we want to really extend, and we have, starting from Friday, we will have 2 more people on board somehow to strengthen our company. As a next thing, why does it not work? Okay. Just my thoughts, I like the bubble at the bottom, so defense budgets, 22 billion Australian dollars globally, just in the drone market. I'm sure in the next years this will increase heavily due to the current situations. And it has a compound rate from 90%, which is really a huge market to address. Also in other sectors like agriculture, drones are a big business. So it's really nice to be in this space. I put the first slide top left there because for me TB2 and TB3 is one example how somebody can really build this complex technology, and I call it a bit a military drone on a shoestring budget, because they really managed to get all the capabilities into their drones. So Turkey, when they built this drone in a very efficient way. And this shows us also how accessible this technology is, how easy, how relatively easy it is to build this technology. When we look then further what others could do by building some swarm drones and which danger they could cause. And so this technology is really end consumer available. So for example, even our drones are built on end consumer products. So all the technology, flight controllers, what we have, this is off-the-shelf components, so it's accessible for everybody. And this is also a reason why then countermeasures are important. So especially if you look for swarm drones, what do you do against the swarm of mosquitoes? So it's a pretty heavy thing. And the second thing what I always saw is all the data amounts coming in a defense context. I think one of the economist articles wrote about Afghanistan, that it was a war of data. There was a lot of sensor data collected, a lot of data fusion had to take place to really find the nuggets in the data to identify the big things. And this is somehow what we want to aim at. So we want to get data from a lot of data sources, somehow mine this stuff, use our AI technology, machine learning technology, somehow to make sense, to create patterns, to see patterns in the data and make this in a human understandable form so that we can form somehow teams with the technology. And provocatively I called it, it's about human AI teaming. So rather than machine teaming, it's about human AI teaming. And maybe in the future it's about AI human teaming because intelligence is rapidly increasing. When we look at the next slide, so we have to say we are very thankful for the D-Start Ignite program from the Department of Defense. And what we heard, for example, during the presentation yesterday is how important it is to work with innovators. So for us, this accelerator meant much. And I still remember one of the mentors there said us, yeah, why do you tell us what we already know? Why don't you go more for visionary scenarios in 10 years? Why don't you push the boundaries? Because that's what you can do as a small company. And we were thankful for this advice because we really said, okay, we need to go beyond this stuff because that's our strength somehow there. So we were part of this program and we're very thankful for having been part to learn the language, to learn how to talk to you and somehow get an understanding of your requirements. The second thing where we apply it now, because for us it's easy to map defense scenarios in the agricultural sector because we have the data, we get the data there, it's freely available, or partially freely available, but it's easier to map some of the scenarios what we learned as part of the program in agricultural context, where we want to fly really autonomous drone, which is somehow in a virtual in hangar at the farm for certain missions, and we selected 4 mission scenarios. So one is just fly to certain points of interest on the farm in an autonomous fashion. So that was one of the scenarios. The second was turf care, where you can see the conditions of the turf, so we can use our image processing and all sorts of stuff. And one is save the farmer, so it's an emergency situation where the farmer is somewhere on his farm, there's an alarm or something going on. And one is where you can find, for example, persons or when he's somewhere had an accident and identify where he's located and all this stuff, but comes from a defense scenario. And the second one is mustering, but we will hear a cool presentation at the end about sheep. So this is what we started off. And we see also the problems now associated with drones. So when we look to natural disaster management, where drones were mixed with normal aircraft in the airspace for, in a bushfire situation, we see already some of the problems there. So teaming is essential because you don't want to interfere with the normal aircrafts, with the, fire aircrafts, whatever is around there in the air, together with drones. So that's one of the problem sets. One other one is ISR missions, what we have been looking at, because I did quite a bit of image processing stuff. So this fits somehow to the things what we can do. But there are a lot of other problems, and these problems are somehow coming from the D-Start Ignite program, what we identified, like you need huge teams when you operate drones. Then there's a lack of efficiency there. So a soldier on the field is incapacitated when he flies his drones to get some data. So we want to solve this one. And we want especially to look for the human factors there. So how can we really team up human beings with the machine, basically? So therefore we developed this one, and that was also based on one discussion what we had with this special person in the D-Start program. So we typically the workflow is you identify the location, you plan your mission, and you have the flight ban, you put some semi-automated system there, but we want to look at the other side. So we want to look how to capture certain events which are taking place, how to report this back, how to collaborate with a human being, how to communicate this back to the human which is operating the drone, but event-based, so it should happen in an automated way. We look at the analysis and decision support, so we developed some small dashboard solution which should support decision-making in either real-time contexts or in non-real-time contexts. And we look at the human performance, so how can we get the human AI performance? How can we increase the things there? So this is what we are looking at. So we can do quite a lot of stuff. So we can work with, there are some screenshots with topographical data, digital elevation models. We can work with LiDAR data, thermal imaging, and this is our prototype drone. So we called it Kiwi 001. So if somebody is here from New Zealand, that comes from birds which don't fly, but ours are flying. So it's our octocopter. It's a standard platform, off-the-shelf equipment, and what we can build. And this is our vision for farming on top left. So we really want to get some chat application, like thing running with the drone, because it's a simple user interface which a farmer can interact with. So it's, for us, it's also from a technology channel, it is simpler. And the other thing is a video, so we can do virtual reality models where you can fly certain points of interest along some pathway, where you can use scanning technology or 3D, where we can model basically images into 3D and you can fly according certain things. So this is a bit this thing. So we are happy that finally May we get our platform together. So it's a bit a standard cloud-based platform, where we have data sources where we try to ingest mission-relevant data sources, put it into our system, and then can develop our machine learning AI platform on top. And then we have some front end, which is open layers we use for the drone and ground station, really off-the-shelf technology, Raspberry Pi, it's just the standard flight controllers and all sorts of stuff. So this is somehow the thing what we will launch in basically in May already. And we are happy about this. So this is just another view of the stuff what we are doing. Mission planning, flight planning, this is more the stuff what we are only partially looking at because there are other companies which are doing that. But we look at the analysis decision board and some dashboard solution. And this is a quick mock-up what we developed during the D-Start program. So we really want to somehow get factors inside like teaming performance. How good does human AI teams, how good do they work? What is better to let autonomously done? What is better when a human is there? How can we develop some trust matrix in AI? So how can we do that? Some risk analysis, what are the risks when what is doing? And then the human performance side of things. It will look a little bit different because we started tests in December this year in the context of farming. So we want really to try this in the agricultural side, but of course shift the thing here. So that's my last slide now. That's our founding members. The intelligence is sitting here, so that's not me. So that's the lady which is sitting on the left to me. That's my co-founder. And basically what we are looking for is we are currently we're still looking for steering board members for a collaborative research grant, which we do together with the University of Western Australia. And we still look from the defense side for steering board members. And we are really open for any customer-driven project, somehow in the drone space, mission planning space, either if it's some specialized software there, customized drones, or something which is related to human factors or cognitive load or cognitive workload.
All right, many thanks for your presentation. I'm just going to repeat that into the microphone. So the question was related to agricultural settings.
Wondering what sort of agricultural settings and terrain you are considering for your actual drone applications?
I think from the terrain we're a little bit independent. We're just in Western Australia, so we work with a local farmer there together, but it's just a wheat field basically. So it's not very rocky or mountainous. So it's just, from an Austrian perspective, pretty flat. So if you mean that one, and it's simple scenarios. In other words, scenarios like is the gate opened, or where's the water thing, or just some hotspots at the farm, where the drone should regularly fly to and report things back. For turf care, this was more about, we talked at this time, it was not farming, but a golf club which wanted to see, how the condition of the grass is and all this stuff. And for mustering, it was really heavy terrain. So, but we don't go into mustering, so it was a bit too complex for us. But you will solve that most likely before us. But it's for mustering, the problem is there, the terrain, because sometimes they're going by motorcycles around, put the cattle back. And there the terrain is actually, with a drone, I see it a bit more terrain agnostic, so I don't think that the actual terrain would be a problem for us with drones actually.
Any other very short burning question from the audience here? Yes.
Yes, sorry, I've got a question if you don't mind. The term autonomy and artificial intelligence is often used interchangeably. I'm really keen to understand how far you are down the artificial intelligence route, where the drones will make decisions themselves rather than follow the pre-programmed algorithms that you've been describing in your presentation. Thank you.
Yeah, from the autonomy side, so basically there are different stages. So one is the mission planning stage. And let's say, so basically we get all the data from LandGate. So LandGate, has, for example, terrain models and, for mission planning. So we try to do this at mission stage as much as possible because it's simply easier for us. And then, of course, on the drone, you have like small, tiny LiDAR sensors to detect if there is something in the thing. You have some vision-based sensors and all this stuff. That's at the moment the intelligence in the drone. So at the moment it's during mission planning, and the thing what we want to do is then to learn out of missions afterwards, so that we have some machine learning AI tools or interchangeable. It's anyway people mean all the time talk about the same, and then afterwards then how to do the image processing from the data which is collected. So partially we can also do that in real time, and that's sorry. Okay. I think, yeah, then, yeah.